Hello everyone, my name is Alex, and today I'm going to present you GitHub Actions on Kubernetes. To provide a bit of context, Actions is a product launched in 2018 by GitHub and is one of the most used CI systems nowadays, with a powerful presence in enterprise and open source projects. Ranking second only to Jenkins, according to the developer ecosystem report for 2023 by JetBrains, Actions is close behind and even surpasses Jenkins for personal projects. I know a lot of you presented Jenkins today. Actions are using runners to execute the jobs defined as YAML configuration in our repository. GitHub offers their own hosted runners, allowing workflows to run in GitHub virtual environment. As an alternative, there are self-hosted runners, which you can run and customize in your own infrastructure. For this particular event, I will focus running GitHub Actions self-hosted runners on Kubernetes, which provides as advantages automatic runner auto-scaling down to 0 based on demand, short-lived runner pods that allow builds to always start in a clean environment. Probably you already have that infrastructure available somewhere. Some of the disadvantages for Actions on Kubernetes are cluster operation overhead for spinning up a new cluster, additional CRDs, and complex custom image setup if that's required. We'll go through the main way to run Actions on Kubernetes, which is the Actions Runner Controller. The Actions Runner Controller, or short ARC, is a Kubernetes operator that orchestrates and scales self-hosted runners for GitHub Actions flows. This is an open source project currently developed in partnership and maintained with GitHub. ARC creates a few custom resources that automatically scale pods based on your workload. Here we can see a diagram of the main resources used, with the management components and runner pods being deployed in separate namespaces. An ARC deployment applies these resources onto a Kubernetes cluster and creates a set of pods that contain your self-hosted runner containers. With ARC, GitHub can treat these runner containers as self-hosted runners and allocate jobs to them as needed. Here we have the command to deploy the controller in CRDs using Helm, and this will install the ARC scaleset controller chart in its own namespace, the ARC systems namespace. After we install the chart, we can see the controller pod running. And now we can start and configure everything else. Now that the controller is set up, we should generate a personal access token or create a GitHub app. In our example, we use the preferred way, a GitHub app key, and configure a runner scale set. It is recommended to provision the scale set in a different namespace, keep the GitHub credentials as Kubernetes secrets, and just pass its reference. Here we have the command to create a Kubernetes secret with the app ID, installation ID, and the private key. We create or use an existing runner group set in our GitHub settings. Runner groups are used to collect sets of runners and create a security boundary around them. Defining the group at organization level will allow us for a granular repository access policy to the runner group. For example, we will use this arc runner set 01. Then we fill the scale set chart values to allow the listener application to authenticate to GitHub. This will establish an HTTPS long pole connection to check for our jobs. In that command, GitHub config URL sets to either an enterprise, organization, or repository URL. In our particular example, we set it to our organization. GitHub config secret is the reference to the secret we created earlier. Runner scale set name will be used as the base name for our Kubernetes resources, and runner group will be used to target this replica set in our actions. After the chat installation, a new listener pod will be created in the ARC namespace, and that will poll for any new workloads. If we install multiple scale sets, for each subsequent one, a new listener pod will be created. The listener stays idle until it receives a job available message from the GitHub Actions service. We now should have the runner sets available in the organizational level runner groups. And to use these new runner groups, we set the runs on key in our Actions YAML configuration to match the pods in our recently deployed scale sets. When the runner scale set listener receives the job available message, it checks whether it can scale up to the desired count. Triggering this job, we can see the pods getting created, running our defined steps, and getting terminated. Throughout the job run configuration execution, the runner continuously communicates the logs and job run status back to the GitHub Action service. In conclusion, GitHub Arc is a great way to isolate execution environment and allow automatic scaling for large workloads. It might be a bit hard to get a new cluster up and running, but Azure and AWS should help here. For code snippets and the official documentation, you can scan the QR code on the left-hand side, and that's all for me. Thank you.
Thank you, Alex.